Hello everyone. So today what I want to do is get a video together where we're going to do some demonstration problems and group works and just some more practice with looping. Um, so the general idea here is going to be I will show the problem. I will expect you to just pause it, try to figure it out on your own, and when you're ready, just play through and then see how I get to the solution. And if you have any questions or anything where you think, oh, would this work as well? Feel free to ask me or any of the other tutors that are going to be available online. Uh, and yeah, okay, so let's get started with the first one. The first one here is a full program, and we have some comments that are trying to guide us through the process. So we have some constants, integers, so a start, stop, and a num per line. And if we read the purpose here, the program demonstrates how we implement a count-controlled loop which outputs all of the odd values in a given range of numbers. So this given range of numbers starts at this constant, stops at this constant, and is inclusive. So we need to make sure that we include that stop number. And now this num per line is the number of values that we want to write per line. So we write 10 integers and then skip to the next line. So there's a lot of ways that we can do this, but if we get started here, we see that we already have declared a variable num values, the total number of values in a line of output. So basically we can just check this and say, well, if this equals this, then we can output a new line character. Okay. So the user prompt, don't need to touch anything from this. We're not getting any input from the user. And we have more instructions here. Code a properly structured count-controlled loop, which outputs all of the odd numbers with a space between them, with num per line values to a line, from start to stop inclusive. So, if this is a count control loop, we can do this. Let's do this as a while loop first, because that's what the comments are kind of hinting at, and then let's change it to the more correct for loop. It'll be really easy to convert, and we'll get practice with that as well. So first thing that we're going to do is our LCV is count. See, we've got a comment with LCV. So our count, when we initialize it, we just want to set it to whatever the starting value should be, and the starting value should be start. That's the constant declared above here. So this is what we want to start at. Now the loop test will say while count is less than or equal to stop. Because it is inclusive, so we want to include this value, which is 713. So when we get to 713, we want to execute one more time. All right, now the loop body, what we want to do is, if it's an odd number, we want to output it with a space between them. Okay, so if our count mod 2 equals 1, then we know that it's odd. And if the number is odd, then we want to see out the count. And we want to put a space there. So we'll output the number and then a space. Now, next what we want to do is we want to say num values plus plus. Because this is the number of values that we've written out to the screen on this line. So if I say if num values, like I said earlier, I want to use num values and compare it to num per line, and say, well, if these two values are the same, then we want to see out an end line and set num values back to 0 because we moved to a new line. So really our first iteration will come through and we start at 5, so that's an odd number. So we will go in, we'll output 5, a space, num values plus plus. Okay, that we come to here, so num values is 1. 1 is not equal to 10, so we don't output the next. We go through, boom, 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 num values is 9, plus plus, it becomes 10. So then we say, okay, we've outputted 10 numbers, num values is 10, num per line is 10. We output our end line, and we reset it to 0. And the next time that we come back through, we will increment num values again. Okay, I think this will work. So if we come down here to step 4, we need to modify the LCV. Well, how do we modify the LCV? Easy, just count plus plus. Oh, I'm just now realizing one small issue here. We don't always output a value, so we really need to put this inside the if statement. Because if we don't put it inside the if statement, then it'll count every single number and not just the ones that we're writing. Okay, so I moved that into this if block. So step 4, modify the LCV. Okay, this all looks pretty good. Let's check it and see if it works. Awesome. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 per line. It gets a little funky because we didn't do any padding or anything like that, but that's fine. We don't need to do anything like that. So this program works. The only thing that I really want to do though is just to do a cout end line right there so that it looks a little bit nicer. And then let's go ahead and convert this into a for loop, which would be a more correct way of doing a count control loop, right? So I am going to take all of this code and I'm just going to comment it out by doing a /* and deleting that asterisk / and then moving it down here. So now this whole thing is commented out. So then I can come down here and I can rewrite it and it won't execute twice. So well, we have our LCV here, and it's already being declared there, but remember in a for loop, we get the benefit of declaring and initializing it all in one go. So I'm going to declare and initialize count right here. So int count equals start. So that's the declaration, and that's the initialization all in one go. Okay, what's the next step to a for loop? Well, the next step to a for loop is we are going to need to put in the loop test. So what was our loop test? Well, our loop test was right here. That's not going to change, so let's just copy and paste it. And then now, what is our modify LCV? Well, our modify LCV is just count plus plus, and that's not going to change, so put that in there. And now, when we're in here, we just need our loop body, which is all right here. So we just copy that, paste that, save it. So count, yep, and it all looks exactly the same. So let's just really quickly run this and just make sure that it does actually look the same. Yeah, it definitely looks the same. And that's it. 2 different ways of doing the same count controlled loop. I'm definitely more impartial to the for loop here. The way that this was structured, though, told me, oh, they want me to initialize the LCV in one line, declare the loop test in this line. So that's more of a while loop thing because you have to set all that stuff up yourself. So using those contextual clues, I was able to figure out that it probably wanted a while loop. But I wanted to also demonstrate just how easy it was to take it from that while loop to a for loop, and vice versa. All right, so let's get ready to move on to the next one. All right, so next we have just a few fill in the blanks, answer these questions about loops. So this is one question. Explain the advantage of creating a loop. And then this is a single question. What are the 4 steps involved in creating an end-of-file loop? And give a brief description of each in your own words. So this will be important to be able to not only know what each step is called, but also a quick explanation of what it does. Make sure that you understand why all the steps are important. And then lastly, did you need to know how many values were stored in the data file? would this loop work for a file with any number of values? Explain why or why not. So take a minute, try to answer these on your own, and then when you're ready, hit play and see what my explanation is. All right, so what is the advantage of creating a loop? Well, it allows us to repeat code. So we can repeat code without copy and paste. It also allows us to repeat code an unknown number of times. So we can have more complex logic like we don't know, we're trying to validate the user's input and we don't know how many times that's going to take. How many times is it going to take before they finally, input it correctly? We can't say. So we couldn't just copy and paste, hey, see in this number of times and the user will have input something correct. No, we really do need looping for this. And we never want to duplicate code because if the more code that you have, the more likely you are to have bugs and issues. So looping really helps with this. Okay, so the next one, what are the 4 steps involved in creating an end of file loop? Well, step number 1, this is our priming read. So remember, our priming read is we've already declared our LCV for the end of file loop. And that LCV is basically our DIN variable. So our DIN variable being of type ifstream. So we opened up the file, and as long as the file exists, we can do our priming read. So we need to check if the file exists. So the file does exist, so we do our priming read. And now a brief description of this step, I would just say that this is just like reading our first line of data. Reading first part of data. And I want to come back to why we have a priming read step here in a minute. But the next part is going to be our loop test. So what is our loop test? This is, did we successfully read data, basically. This is our while DIN. So while there was still data read from the file, we need to continue to process it. So our loop test is checking that we read data from the file. So our first loop test, we're checking to make sure that our priming read read data from the file. And if we're at the modify LCV step, which is down here, then our loop test is checking to make sure that that step successfully read something from the file. Because if we didn't read anything, we don't have anything to process and we need to exit the loop. Okay, so step 3, we have our loop body. And our loop body, I can't say anything about it because I don't know what the loop body is for this example, but it's where all of the actual work happens. Everything else is just to accommodate us to be able to read a whole file. This is where we actually process the file. Whatever we want to do with the inputs in that file, we would do it there in the loop body. And lastly, we just modify LCV. So modify the LCV, just like this says reading the first part of the data, I'm going to say that this is just reading next part of data. And yeah, so if we look at this, what is the point of our priming read? I mean, other than the fact that it gets us set up to go into the loop test and then go into the body, if we moved the modify LCV up and just made that the first thing that we do, the issue that we run into is, well, we would have to put it after the loop test, and so if we read something and we didn't successfully read a value from the file, then we would process it in the loop body. So we can't have anything like that. And if you didn't follow that's fine. This is a little obtuse of an explanation, but the whole point of this priming read is, what if we successfully opened up a file, but the file is empty? This priming read allows us to try to read that first value, and if there was nothing read, our DN flag will switch to false. So then when we get to the loop test, we don't execute at all. We just exit out of the loop right away because there was no data. There was nothing to read. There's nothing to process. So we don't need to go into the loop. Okay. So this next question, did you need to know how many values were stored in the data file? Would this loop work for a file with any number of values? Explain why or why not. So no, we did not need to know how many values there were. We didn't need to know how many values there were because we're just going to keep going until DN is false, and DN has to eventually be false because we're just continuously reading from that same file. We're not restarting reading the file or anything like that. That would cause us to go into an infinite loop. So would this loop work with a file with any number of values? Yes. Yes, it would. Now, the explanation, though, of why or why not is, well, let's think about what the two. I'm going to assume that they mean that the file has to exist. So that we've already accounted for the fact that the file does exist. So there's really only two situations I can think of. One is an empty file. So an empty file, this would be just a file that exists but has no contents in it. So this one would be handled by the case where we read the priming read, we didn't get anything, so we failed the loop test, and then we exit out. We go around the loop body and around the modify LCV. So that case is taken care of. We're good. Now the second case is a full file. And a full file, well, that's our normal case, really. That's we do our priming read, we do our loop test, we do our loop body, and then we modify LCV reading the next value. And we're getting, every single time that we modify the LCV, we are getting closer and closer to the end of the file. So we know that eventually we will read all the values from the file. And we also know that we won't say skip the last value of the file, because when we read the last value, our loop test doesn't say, is this the last value? What it says is, did we successfully read from the file? And that is still true. So then we execute the loop body, and then we modify the LCV. And then when we modify the LCV this last time, when there is nothing left in the file, then we failed to read from it. When we go back to the loop test, this will be false because we didn't read anything from the file. So then we would exit, and that would all work just like we planned. So I would write a little something like that, but rather than writing all that down, I'll just leave that there. All right, so moving on to the next one. All right, so for this next example, we have just a little snippet of code here along with 4 questions. So we're going to take a look at the code snippet and then try to answer all 4 of these questions. So go ahead and pause the video right now, try to answer these on your own, and then when you're ready, hit play and listen to the full explanation. Okay, so reading the code really quick, we see that this is a for int count equals 0, while count is less than 10, count plus plus, cout count, and line. So since this is count less than 10, it's 0 through 10 exclusive or 0 through 9 inclusive. And we're incrementing by 1. So that's why 0, 1, 2, 3, all the way up through 9. So we're going to see out 0 through 9 on separate lines. Okay, that's what the for loop does. Now let's start by reading the question. So question number 1 says, identify what type of loop this is. So we're not asking for the loop structure because that would be a for loop, but this is a count control loop. Okay, so a count control loop. Because we're just keeping track of a count and we're incrementing each time that we do it, and we're doing this loop a finite number of times. Remember, the other type is an event-driven loop, which has itself 3 types, which is the sentinel controlled loop, you have the flag controlled loop, and then you have the end of file loop. Okay, so number 2, convert this from a for structure to a while. So this for is definitely a more appropriate structure for this count control loop, but let's see how we would we've done a lot of converting from whiles to fors, but let's do a for to a while and just see how this would work out. So first I'll declare my LCV int count and set that equal to 0. So I'm declaring and initializing my LCV. And then my loop test is right here. It's the count less than 10. So when I come down here and I do my while for my loop test, I will do it the exact same way, where count is less than 10. Whoops, not a semicolon there. Curly braces. Curly braces. So now, so that's step 1, initialize LCV. Step 2, loop test. Step 3, loop body. Well, the loop body here is just cout, count, and line. So I'll do that. That's meant to be a semicolon, not a J. And then the next step is modify our LCV. Well, modifying our LCV is right here. It's count plus plus, so I'll just write that here. And that's it. So this is int count equals 0. That's initializing, declaring our LCV. Count less than 10, that's our loop test. Cout, count, end line, that's our loop body. And then count plus plus, that is our modify LCV step. So moving on to number 3, can this be converted to a do while? Can this be converted to a do while? So yes, we could, as long as we knew that we wanted to do this up to 10, but there would be some things that would change with it, right? There would be, I mean, we could get the exact same output, but there are noticeable differences with a do while versus a regular while or even a for loop. The do while is a completely different thing, so I'm going to say yes to answer that question, because if we look at number 4, what would be notably different if you did change to a do while? Well, the one thing that would be notably different would be that we would execute the loop body before the loop test. So while in this example here, a do while would work because we're going from 0 through 9, we could do that with a do while, no problem. But if we ever changed anything to where our loop test might not be true for that first pass, that would completely change what we do, because a while loop, if the loop test fails initially, will not execute the loop body even once. A do while, however, even if the loop test was to fail at the beginning of the loop, well, we don't do the loop test at the beginning of the loop, we do it at the end of the loop. And since we do it at the end of the loop, that would cause different behavior. It would execute the loop body at least once. So that's just worth noting. All right, now let's just for fun here, let's do this conversion to a do while. So get some space here, and we'll do int count equals 0. So there's our loop control variable, and then we have a do curly brace. Now we still have our loop body just like this, so here it is. It's going to be cout count end line. And then next we have our modify LCV, which goes in the exact same spot. Count plus plus. And then our close curly brace here. And then now we write while, open parentheses, and then we put our loop test down here. So our loop test stays the same, count less than 10. And then don't forget semicolon at the end of the do while. So this will produce the exact same output as this while loop. You could argue, like, there's never a point where you would actually want to make a do while that is a count controlled loop, but it's a good exercise anyways to get you starting to make some do while loops. So that wasn't asked for up above, but it was good to do anyway. All right, ready to move on to the last one. Alright, so the last example here, we just have a code trace. So given this code, what will be output to the screen? So take a few minutes, really take a look at this, and pay attention. There is some trickery in here. Not too much, not trying to fool you too much, but there are some tricks in here. So you can tell that this is a double for loop, so there's a nested looping happening. So let's not let that confuse us here. And yeah, so pause it now and try to figure this out, and then play when you are ready. Alright, so let's get started. Now, in blue, I'm going to write all of my notes about the variables and stuff over here, and then I'll use red for actual output that happens. So this is a for int I equals 0, while I is less than 3, I plus plus. So okay, this is just starting at 0, going up to but not including 3. And then that leads directly into an int j equals 1, while j is less than or equal to 3, j plus plus. So we have two loop control variables, an I and a j. J starts at 1, and it goes up to and including 3 because it's less than or equal to 3, j plus plus. And then inside of that, we have an if statement. If j mod 2 equals 0, so basically if j is even, then I goes up by 1. Now I being this loop control variable. This loop control variable is in scope between these curly braces, so that would work. That would modify that LCV even outside of this, where we would normally want to modify the LCV. But this is a valid use case. Maybe we would want to do this. The code's written a little confusing, but it's kind of by design. But if it's not even, then what it does is it couts I space j and then an end line. Okay, so let's start this now though. So we declared and initialize our LCV, so we end up with I over here, and we'll go ahead and make a little bucket for it, and we'll set it to 0. Now next we have j getting declared and initialized to 1. J is 1. Oh, sorry, I skipped this step right here where I gets 0, and then we check is 0 less than 3. That is true, so we go in. And then now j is 1. J of 1 being less than or equal to 3, that's true, so we go in. And we say, well, was 1 mod 2 equal to 0? That's not true, so we go into the else block and we cout I space j. So down here we end up with I 0 space 1. And then we move on to the next line. So we're at the bottom of this for loop. We go back up to the top of this for loop. Don't mix that up and go back up to this for loop. No, 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 no. We need to do this inner for loop before we do anything else. So j plus plus. So j becomes 2. And we say, is 2 less than or equal to 3? Well, that's true. So we go in and we say, if j mod 2 equals 0. Well, 2 mod 2 is 0. So I plus plus. So I goes from 0 to 1. And then we skip around our else block here. And now we're at the bottom of the loop again. So we go back up, j plus plus. So j goes from 2 to 3. Now is 3 less than or equal to 3? That's true. Less than or equal to 3. So it's still true. So then we say, if j mod 2 equals 0. Well, 3 mod 2 is 1. It's not 0. So we go into the else and we see out our I, which is 1, a space, and then j, which is 3. And now we're at the bottom of this loop, j plus plus. So j goes from 3 to 4. And then we say, well, is 4 less than or equal to 3? That's false. So we exit out of the for loop and we're down here. Now, we've exited out of this loop, so j is destroyed. We don't have a variable j anymore. Now we're at the bottom of this loop, so we go back up to the top and we do I plus plus. So I goes from 1 to 2. And we say, is 2 less than 3? That is true. So we go inside the loop, and now we begin executing this for loop again, where we declare and initialize j. So let's do that again. J gets initialized to 1, and we say, is 1 less than or equal to 3? Well, that's true. So then we say, if j mod 2 is equal to 0. Well, 1 mod 2 is 1, so that's false. So we go into the else. And when we go into the else, we see out I. So we end up outing 2 space 1. And then new line. Now at the bottom of this loop again, we go back to the top. And j plus plus. So 1 turns to 2. 2 is less than or equal to 3. So then we say, if j mod 2 equals 0. Well, that is true, because 2 mod 2 is 0. So then we enter into this if statement in I plus plus. So 2 turns to 3. And then we skip out of the else state. We go around the else, and then go back to the top of the loop, j plus plus. So 2 turns to 3. 3 is less than or equal to 3. So then we enter here and we say, if 3 mod 2 equals 0. Well, that is false because 3 mod 2 is 1. So we go into the else statement and we see out I, which is 3, space j, which is 3. And then another end line. So we're down here. So we're at the bottom of this loop. We go back up. J plus plus. 3 turns to 4. Is 4 less than or equal to 3? Well, that is false. So we exit out of the loop and we're back down here again. And now that we're exited out of that loop, J is destroyed. And then we go back to the top. I plus plus. 3 turns to 4. Is 4 less than 3? That is false. So we exit out of the loop and we continue on our way. And I would be destroyed at that point too, just so that I'm consistent with that. So this would be the output for this code. All right, I hope that was helpful. Let me know if any of this didn't make sense, or ask a tutor for some help if any of these answers didn't make any sense. All right, thank you.